Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, welcome students to TV learning programs. Once again, I'm Teacher Julius, and today I'm going to learn with the senior 4 students, economics. And we are still on our unit 4, which is equations and fractions in economic models. Equations and fractions in economic models. And our lesson title, we want to look at how we can apply all the applications of differentiation in economics. And what do I expect you to be knowing at the end of this lesson? Learners, I expect you at the end of this lesson of 30 minutes to be able to apply differentiation in economics. We apply under this unit, our unit 4, we have looked at different things that are related to mathematics. We have talked about a lot of mathematics under this unit. So we apply mathematics in economics. So now our today's lesson, we are going to see how we apply differentiation in economics. So if we continue, so what is differentiation? As you can see, differentiation, we are saying it is a process of obtaining a derivative function. So under this unit, we are going to see briefly how you can get a derivative function from a given function. So differentiation is the opposite of antiderivative. Antiderivative, those who do mathematics, that will be integration. So in this case, we shall have, for any given function, as you can see, for any given function, if we have this one as our function, f of x equaling to x power n, how can we obtain a derivative of this function? So how do we indicate a derivative of a function? So our first derivative of this function, we shall write it in this case, which in this form, which shows a derivative function. This is a derivative function. So if this is our function, how do we get a derivative? How do we differentiate it in this case? So we have our x power n. This n is a power, is an index. This is a power. So how we carry it out, or the formula that we shall be using in this unit, on this lesson, you bring this power this side. So we have our n here, then you multiply with this figure that we shall be having, our x, then our power, this n, you subtract 1, you reduce it by 1. So we shall be, we are going to apply this, this rule number 1, generally, for any, in this that we are going to do. So the derivative of this function will be n. You bring this power, n is a power. It can be 3. You bring that 3 here, then times the figure that you have here, then power this n, then you reduce it by 1. So this will be the derivative of this function. So this is a derivative function of this function that we have. Then from there, I want us to look at some of the examples, how we can get the derivative functions of different linear equations or linear equations and quadratic equations. So we have these 3 functions. The first function is a linear function. So if we have our first function, f of x equaling to 3x plus 9. So how can you get a derivative function of this? So you have to first know this. So our derivative function of this will be, if you try to differentiate this, here our x, it has a power of 1. Any number to power 1 is that number. So this is power 1. So you have to bring that 1 here. You have to bring this 1 here because when you bring it, then times this 3 that we have, we are following this general rule, then times x, and remember our x, it is power 1 minus 1. Then when you differentiate a constant, this is our constant. When you differentiate a constant, you get 0. When you differentiate a constant, you get 0. So in this case, when you get 1 minus 1, it is 0. And here when you get 1 times 3x, it is 3x power 0. And remember, any number to power 0 is 1. Any number to power 0 is 1. So in this case, it is 3 plus 0, which is equal to 3. Here, this x power 0, any number to power 0 is equal to 1. So 3 power 1 is 1. So this is when you differentiate this function that we have here, our linear function, you will come up with 3. And when you differentiate a constant, you get 0. So the differentiation or the derivative of any constant is 0. Then we have our second function, which we have, it is a quadratic function, which is 10x squared, 10x squared plus 2x, then we have minus 5. So how can you get the derivative function of this? So our derivative function, f prime of x, this means the first derivative, will be equal to our first derivative of this function. So this 2, this is our power, you bring it here, you multiply it with 10, so that will be 20x. Then here, when you subtract 1, you remain with 1. Plus, this is 2x. X, it has a power of 1. And remember, when you differentiation, here you must reduce it by 1. When you reduce it by 1, you remain with 0. So x power 0, any number to power 0 is 1. So you remain with 2. When you differentiate a constant, this is a constant. It gives you 0. So plus 0, you may not indicate it. So finally, our derivative function of that is 20x plus 2. So that is our derivative function of this. Then we have that one. Then after we go to the application, we have our function f of x, which is equal to 4q cubed minus 20q squared, then plus 5q, then plus 30. So how do you get the derivative of this function following our rule? So our derivative of this function, so the 3, you bring it here. This is our power. You multiply it there. Then you will get 12q square. Why am I getting this square? Because the 3, you reduce it by 1, following our rule. Then you bring this 2 here. When you multiply it, you will have minus 40q. Minus 40q. Then plus, when you differentiate 5q, you remain with 5. Then plus 0. This is a constant. And when you differentiate a constant, you get 0. So finally, this becomes our derivative function. Now, how do we apply these derivatives in economics? Now, we have application number 1. These derivatives or differentiation, we apply it when we are calculating what we call marginal revenue. Marginal revenue. This is application number 1 now. Marginal revenue. So marginal revenue, how do we calculate it? So application now, as you can follow. So application number 1, we are saying we apply it when we are calculating marginal revenue. Marginal revenue. When calculating marginal revenue. So what is marginal revenue? Revenue, this is the income that a business gets. And when you say marginal revenue, additional revenue generated by the business after selling an extra unit of output. After selling an extra unit of output. Marginal, additional revenue, additional income generated by the business after selling an extra unit of output. So here, we shall say that our marginal revenue, how do you get it? Marginal revenue. Here, it is a change, a small change in total revenue divided by change in output. Change in output. So here you must know that TR is our total revenue. This is our total revenue. Then our Q here, this is our output. So we shall use this. So here we differentiate the total revenue function with respect to output. We find the derivative of the total revenue function with respect to output. With respect to output. And how do you get total revenue? This is what you should know, that total revenue, how do you get it? You get price, total revenue, total amount of money generated. You will get the price of goods that you have sold. Then you multiply the output. You multiply the output. If you have produced 10 bottles of water, that is your output. Then each bottle is at 500. So when you get 500, you multiply by 10 bottles of water, you will get total revenue generated. You'll get total revenue generated. So now let's see an example now. We have an example whereby we are saying if a firm faces a demand function given by P equaling to this, find the total revenue function, find the marginal revenue function, and marginal revenue when Q or output is equal to 100. So how do you go about that now? Our example one, let us try to solve it. Let us try to work out our example one, which we have there. So we have the demand function, which they have given us as P, which stands for price, 800 plus this output. So they want us to find total revenue function. Because remember, to get the marginal revenue, you must be having the total revenue. So how do we get it? From this formula, we know that total revenue is price times output times quantity. So our total revenue will be equal to price times output. This is your price, which we have 800 plus Q, then you multiply by Q, this one that we have. Price, this is a matter of substituting, then times quantity that we have here. So when you multiply this, what will you generate? We shall get Q times 800, that is 800 Q, then plus Q times Q, you get Q squared. You get Q squared. So this is our total revenue function. This is our total revenue function. This Q must be multiplied throughout the whole bracket. Q times 800, 800 Q. Then Q times Q, you get Q squared. Where does the square come from? This is a power 1, a power 1. And remember, when you are multiplying numbers of the same base, you add the powers. You add the indices. That is where the 2 is coming from. So this is our total revenue function. This is our total revenue function. Total revenue function. Total revenue function. Then we can get the marginal revenue function. Remember, to get the marginal revenue function, additional income realized after selling an additional unit of output. We differentiate the total revenue function with respect to output. So here, our marginal revenue, we are saying is equal to the small change. We differentiate total revenue function with respect to output, which is equal to. So we have this one as our total revenue function, 800 Q plus Q square. We have 800 Q plus our Q square. So if you differentiate this, what do you get? What do you get? What do you get if you differentiate this? Here, our marginal revenue function will be equal to, if you differentiate this, depending or basing on our general formula that we have, we shall have 800 plus 2Q as our marginal revenue function. Where does this one come from? Remember here, the Q, it is power 1. When you bring 1 here, 1 times 800, it is 800. And when you subtract 1, you remain with 0. Any number to power 0 is 1. And this 2 you bring it here, you multiply it here, then you reduce it by 1 using our formula there. And any number to power 1 is that number. Any number to power 1 is that number. So this is our marginal revenue function. Marginal revenue function. This is our marginal revenue function. Marginal revenue function. Now, you continue. They are saying you get the marginal revenue when output is 100. So that is very simple. When output is 100, what do you do here? You just substitute this Q in your marginal revenue function. So your marginal revenue here will be equal to 800 plus 2 times output Q. But Q is 100. And here your output will be 800 plus 200, which gives you to 1,000 units, 1,000 Guanan francs, if it is measured in Guanan francs. So this is your marginal revenue when output is 100. So you can look at that. If this is maybe your Roman 3, this one being your Roman 2, and this one being your Roman 1. So this is how you apply differentiation or derivatives in economics when we are calculating marginal revenue. Then application number 2, we can also apply differentiation when calculating what we call the marginal cost. When calculating the marginal cost. What is marginal cost? Marginal costs. And what is a cost? A cost is an expense incurred during production of goods and services. And therefore, when you say marginal cost, these are additional costs incurred in production of additional unit of output. In production of an additional. Because of the word marginal, you must bring the word additional. You must bring the word additional. So how do we calculate this? We know that marginal cost, our marginal cost, we shall calculate it by having a change in total cost divided by a change in output. Remember, learners, when it comes to economics or any business, when you say total costs, because TC is total costs. And how do you get total costs? Total costs, you know very well from entrepreneurship senior 4, total costs, you get fixed costs plus variable costs. Total costs is equal to fixed costs plus variable costs. You know that one. And this is output still. So you have to, if you want to get marginal cost, you differentiate the total cost function with respect to output. With respect to output. And I expect you to be knowing examples of fixed costs like rent, expenses. You know, fixed costs are costs which don't change with output level. You know that from break-even point, senior 4. And variable costs, these are costs that change with the production output. That change with the production output. E.g. material, raw material costs, salaries of wages of temporary workers. All those ones are variable costs. So let's look at an example. We have an example. If a firm has a total cost function, this one, total cost function, Q square, that is our which represents output, Q represents output, plus 10Q minus 4. Find the marginal cost function. You have to note this. Find the marginal cost function. After getting it, then you have to get the marginal cost when output is 100. So how do you go about this? This is not very hard. So we have our total cost function, which they have given us as Q squared, output squared, then plus 10Q minus 4. So they want you to get the marginal cost function. How do you get the marginal cost function? So the marginal cost function, we shall differentiate the total cost function with respect to output, which we have here because our function is expressed in terms of output. So in this case, when you differentiate our total cost function, to get a marginal cost function, here applying our general rule, the other one, this power, this is Q power 2, so you bring it here. So that is 2 times Q, and remember here you subtract 1, so 2 minus 1 plus, this is power 1. When you bring 1 here, and then you subtract 1 here, so you have to follow that. 1 times 10 Q, 1 minus 1, you know you remain with 0. Then the differentiation of a constant, it gives 0. When you differentiate this constant, it gives you 0. So in this case, our marginal cost function is 2Q, 2 minus 1 is 1. Any number to power 1 is that number. That's why I'm not indicating 1. Then plus 10 times Q power 0. Q power 0. Any number to power 0 is 1. That's why here we have 10 times 1, which is 10. Altogether, which is 10. So this is our marginal cost function, 2Q plus 10. Then from there, we can get now the marginal cost when Q is 100. When Q is 100. So from there, you have already gotten your marginal cost function. So you can now evaluate, you can get the value of this when you have Q. So when output is 100, what is your marginal cost? Our marginal cost here will be equal to 2 times output Q, which is 100, then plus this 10. And this gives you 200 plus 10, which finally gives you 210. So this will be your marginal cost when output is 10 units. This will be your marginal cost. Remember, to get the marginal cost function, you differentiate the total cost function with respect to output. So differentiation is applied in businesses, in economics, while even we have the profit functions, but those ones we shall not go to, we shall not look at them. Profit functions, we can apply those, the derivatives to find the profit maximization, calculating the marginal revenue, additional income realized by a business after selling an additional unit of output. We have when calculating marginal cost, costs incurred or additional costs incurred to produce additional unit of output. So you have to note this, you have to note this. You know that to get the marginal revenue, differentiate total revenue function with respect to output. So we have, I have this one which you can try out. We have example 2. The firm has a total cost function of that. So we can try to look at it very fast. We have the total cost function, which is 10Q cubed plus 20Q square. Then we have minus 2Q, then plus 30. So they want us to get the marginal cost function and the marginal revenue when Q is 10. So the marginal cost function will be, we shall differentiate this total cost function with respect to output. And when you work out that, our marginal cost will be 3, you bring it there, 30Q squared, plus 40Q, then minus 2. This will be your function. How have we got it? This gives you 0 because it is a constant. Then this is power 1. When you subtract 1 using our general rule of differentiation, any number to power 0 is that number. Then here we have 1, you remain with 1, any number to power 1 is that number. And when you multiply it here, this is 40. When you bring 3 here, times 10, 30, then you subtract 1 here, you remain with power 2. This is a marginal cost function. Then you can get marginal cost when output is 10. So when output is equal to 10, you get this 10, you just substitute it into this marginal cost function. Then our marginal cost will be 30 into 10 square plus 40 into 10. This gives you 30. 10 squared is 100 plus 400. 40 times 10. So this gives 3,000 plus 400, which gives you 3,400. This is your marginal cost. This is your marginal cost. Then, after looking at that, I want you to have this home assignment. I have work for you, which you have to work out following what we have done. Question 1, for a total revenue function, TR is equal to 500 cube minus 2q square. Find the value of marginal revenue when Q or when output is 20. You will first differentiate total revenue function with respect to output, and you get MR, the marginal revenue. Then from there, you'll be able to get it. And marginal revenue, you see how you will go about it. The way we have done this one. How we have differentiated this to come up with this function. Then question 2, if P equaling to 80 minus 4Q is the linear demand function. This is a linear demand function. It is not quadratic. A quadratic function has degree 2, then and above. So this is a linear function because the highest power is 1. The highest power of Q is 1. Find the total revenue function. Remember, total revenue is price times output. Here, total revenue is price times output. So you will get this. You multiply by Q, which is output. After getting that, you differentiate the total revenue function with respect to output, then you will get the marginal revenue function. Then this one, in your marginal revenue function, you will substitute in Q, which is our output, equaling to 10. Then from there, you will be able to get your marginal revenue when output is 10. I think you'll be able to work out that following the directives and following what we have done together. You'll be able to work out that assignment with ease without meeting many difficulties. So try to put down the assignment and try to work it out following all the steps. So I think you have seen how we apply differentiation in economics, derivatives in economics. So thank you very much for watching and listening. Hope to meet you in the next lesson. Thank you.